Okay, so in this video, we want to talk about what are called anomalies when solving equations. If you're not familiar with that word anomalies, it just means strange things that can happen. Okay, and so let's just show you two quick examples. This video will be short. Okay, so let's look at an example here. Say I'm solving this equation right here. 2 times x plus 1 minus 1 is equal to 2x minus 1. Okay? So we go through and we start solving this the way we normally would. All right, and so we would need to distribute first in those parentheses and on the left side. And so I would have 2x plus 2. Remember that minus 1 is just there, so we rewrite it. There's nothing to do on the right side, so I would also just write it. Okay, now notice that we have these like terms right here. 2 plus 2 minus 1, I'm going to have plus 1. Okay, and so now I have 2x minus 1. All right, now you might start seeing something that's strange, but just keep going. Okay, and so remember we usually move our variables over to the left side, so I need to move this 2x over to the left side. How would you move that over? You would subtract 2x, right? So you subtract 2x like that, and now here's the key thing. Don't let this throw you and force something. Here we have 2x minus 2x. Those subtract out, okay? I'll be more explicit here on this first example, but that's 0 plus 1 is equal to, just like over here on the right, they subtract out, so we usually don't write it, and so all we have left is minus 1 over here, okay? But what is 0 plus 1? It's 1, okay? So something strange happened. There's no variable left, and so we can't isolate it. So try not to let that throw you whenever that happens. It does happen fairly common. I won't say, well, it's not even fairly common, but it does happen sometimes when solving equations. It leads into a broader set of problems called ill-posed problems. We don't need to worry about too much about this, okay? But the key thing to realize here is that the variable dropped out, okay? There's no variable left, okay? Like that. And does 1 equal negative 1? Okay, and that's not a true statement. That's not true. Okay, and so the variable dropped out, and we got an untrue statement. Okay, like that. And so whenever that happens, it's this combination right here. Whenever your variable drops out and we get an untrue solution, there's actually no solution to that equation. All right, like that. And so that's actually the answer to that problem, that there's no solution. And what that means is that there's no value of x that I can plug in here to get to check. There's no value whatsoever. And so what we say is that there's no solution to that equation. Now let's look at a similar situation. So, but it's going to be slightly different. But again, you don't necessarily need to recognize it beforehand. All right, you just solve normally. So notice that I have these two sets of parentheses here, one on the left side and one on the right side. So I just start solving normally, so I distribute here. So I have 3x minus, remember to distribute on the back part too, so that's 3x minus 6. And then I have this plus 8 left. And then over here on the right side, I need to distribute that 2. And so I have 2x plus 2, but then I still have this plus x. Okay, so I need to collect terms on each side. On my left side, I have 3x plus 2. On my right side, I have 2x plus x here, 2x plus x. And so I have 3x and I have plus 2. Okay, now this will be a clue later too once we get this down. But just start solving normally again. So I'd subtract my 3x to get my x's over on the left side. But again, they drop out. So on the left side, all I have left is a 2 equals, on my right side, notice that I have a 2 as well. Okay, like that. So don't let that throw you. Now, what's the deal here? 2 does equal 2. So that is a true statement there, right? And so what happened here is that my variable dropped out. And we got a true statement. All right, like that. And now what that means in this case right here, the way we answer that, and that what we say is that any you could just say number, but any real number is a solution. And I'll show you what that means in just a moment. Okay, but this is the way we'll answer it. You don't necessarily need to put that word real into it. The thing about the real numbers is, remember, there's this idea of the number line. We got 0, 1, 2, and -1, -2, etc. Okay, but there's lots and lots of numbers, more numbers. Everything that's between 0 and 1, and everything that's been between 1 and 2, everything that's between -1 and 2, -1 and -2. Okay, so all the numbers on that number line, those are called the real numbers, and that's the reason that we emphasize that. Okay, now what does this mean? All right, what this means is that any number will check into it. Okay, whatsoever. All right, so just to show you that, let's check x is equal to 5, just to start with something basic, and then let's do x is equal, let's think of something really strange, -3.718. Okay, I just made those up. Okay, and what we're going to see is that you might want to try this too. Just make up some random number for x and try to check it, and you'll see that it actually checks. So I'm going to show you that with the video. Okay, and so just remember what the idea is of checking, that I should be able to take my proposed solution and plug it in up here into each side of my original equation, and it should check. So let's do that with x equal 5 first. So I'm going to take x equal 5 and plug it in everywhere where there's an x here. Okay, and so over on my left side, I have 3 parentheses, 5 minus 2 plus 8. That's the left side. And so I get 17. And so now if I plug it in over on my right, I have 2 times 5 plus 1 plus x, so that would be plus 5. Like that. It also gives me 17. So it looks like 17 or 5 is the solution, but it's not. There's actually more than one solution. So now let's check with this -3.718. And so we're going to plug it in to each side here. And just more typing to do, but we have 3 times -3.178. Remember to use that negative key. Minus 2, so then you use the subtraction key. Like that, and then plus 8. Okay, we're going to get a strange decimal number. Don't worry about that. It's just hopefully we'll get the same thing on the right side. So now I plug that x into my right side. So 2 times x plus 1, and then plus x, so plus -3.178. Like that, and hopefully we'll get that -7.534, and see we do. And so that's what it means for any number to be a solution, that no matter what you plug in, it'll check. Okay, so let's just put all this together in a summary. What we're doing is we're solving an equation, but in some cases the variable drops out, and that's what I refer to as an anomaly. Okay, so you're going through, you're just solving normally, and then all of a sudden your variables are gone. All right, so what you do then is you look at what's left in that equation. Okay, and so if the resulting statement is false, remember we got 1 equals -1 at one point. All right, and so then if that resulting statement is false, the answer is no solution. There's no value of the variable that will check in that. Okay, and then if the resulting statement is true, though, like 2 equals 2, that's a true statement. If the resulting statement is true, then what we can say for our answer is any real number. Like that, and that's how you can answer that. Now there's one other thing to point out that you got to be careful of. It's not really an anomaly, but some students let it throw a snag at them, so let's make sure and talk about that real quick. Okay, and so let's see this with an example here. And so here we have this equation, and so we start trying to solve it normally. So the first thing I would do is distribute. So I have 3x plus 12 minus 8. There's not anything to do on the right side. Okay, and so So now I have some like terms to gather over here on the left side, and so we have 3x plus 4 is equal to x plus 4. Okay, I want to start moving my variables over to the left, so I'm going to subtract x from both sides, and so I have 3x minus x is 2x plus 4 equals 4. Okay, now I need to move my numbers over to the right, so I need to subtract 4 on both sides. Okay, and so I have 2x is equal to, and what is 4 minus 4? That's 0. Okay, like that. And so some people get snagged with that and think that this is an anomaly case, but notice those anomalies only come from whenever your variable drops out. But here's our variable. Our variable is still here, so we just proceed as normal, and we try to isolate x by dividing by 2. Okay, and so we get x is equal to 0 divided by 2. And so if you don't remember what that equals, type it in on your calculator to convince yourself of it. But 0 divided by 2 is equal to 0. Okay, like that. And so that actually is a solution. And 0 is just a number. Try to always remember that. 0 is just a number, so that's not an anomaly. It's just that our answer is equal to the number 0. So I'll leave that there, and I hope it helps, and best of luck.